IUPACNamingOfCoordinate.com.
Okay, students, now we are going to start with the coordination compounds. In this chapter, we are going to study today IUPAC nomenclature. Okay, in the inorganic, if there is any chapter from where two questions per every exam are coming, that is the chapter of coordination compounds. Okay, and you will get more than two questions in other chapters, but with the small chapter and lot of questions are there from the coordination compounds. You check any exam, AIMS, NEET, or mains, advanced, everywhere you will find more number of questions from the minimum topic. Okay. P block you will get more number of questions, but the work you have to do is very, very large enough. So it is not that in case of the coordinate complex. Okay. This is one of the minimum study maximum scoring topic. Okay. But only thing you should be able to have your own strategy to solve the questions. Okay. Difficulty tactically you have to deal this chapter. Okay. So now in this lecture I will be focusing on IUPAC nomenclature. Okay. First I will tell you the rules, then I will give you the I have segregated the complexes in such a way. I have taken some wonderful examples so that all concept you learn from the rules you will be able to implement it. Okay. So then this lecture will be followed by the structure and hybridization of the coordination complex. Okay. So let's start with the IUPAC nomenclature first. Okay. So first we will learn the rules, and in again I am saying there is no use of learning only rules until unless you don't practice till the end of the session. We will be having different variety of the questions. Okay. Till today no question came from the rules, but every question solved by using those rules only. Okay. So here first, actually rules for IUPAC in steps are writing the name. It is similar to the organic only. Okay. But same IUPAC formulated, but there are lot of differences. Okay. So once you yourself, or I will try to compare with the organic naming here, then you will understand it easily, because every student starts studying the IUPAC nomenclature of organic compound right from the 8th, ninth class itself. Okay. So if not, at least from 10th class, you will be start studying. Okay, let us use that edge for easy understanding of IUPAC nomenclature. Okay, of coordination complexes. Some rules are common, some rules are different. So if you understand the common rule, then you need not to remember them. Okay. So first of all, in organic naming, you have to follow some order. Okay. Like first it will be primary prefix, then prefix, then word root, then suffix, then secondary suffix. Okay. So like that, in every naming you have to follow some order. Okay. First of all, it is everywhere it is followed. Cation is named first, followed by anion. We never call it as a chlorosodium. We always call it as a sodium chloride, because this rule is already fixed in our mind. Okay. So positive first, negative last. Understood? So irrespective whether the complexes are divided into total four types. Okay, how many types of complexes are divided? Four types. First of all, cationic complexes. Second, anionic complexes. Third, both cationic and anionic, and fourth one is the polynuclear complexes. Okay, polynuclear. These are the four types. Don't worry about them. We will do it separately. Okay, naming we will be doing separately. Is it understood? So, but I want you to continue till the last of this session, because in the last only we are going to apply these rules. Then only perfection will come to know. Okay. So naming of the ligands. Okay. So first let it be complex ion, let it be simple ion. You should name the first cation, and then R positive ion, then followed by anion. Okay. Now in the complex, always you have to write the ligand first, then followed by the cation. Okay. So in the ligand, suppose this is the square bracket. The starting will be metal followed by the ligands. Okay. And you will write in the complex, what is the order you will follow? Write the ligands first, then followed by the metal. Okay. So how to write the ligands? Okay. So ligands are following, I have segregated into the four types of ligands. Okay. So ligands means anything which donates the lone pair of electron to central metal ion. Anything which donates to lone pair to the central metal ion. Okay. So I will give you the rough structure so that you should have a idea actually how it looks like. Okay. So total coordination complex can be assumed as a three concentric spheres. How many concentric spheres? Three concentric spheres. Okay. So three concentric means all of them are spherical, not circular. Okay. I'm drawing circular because it is a two-dimensional one. Okay. Now center will be the metal ion. Understood? Then second will be the ligands. Second will be the ligands. Then counter ions. Then there will be counter ions. Okay. So let me take an example. Suppose K4 FeCN6. Okay. So here where this Fe will be there, here Fe will be at the center. Understood? Now this is of the suppose +2. Oxidation number is what? +2. Okay. And this 6Cn minus are ligands. Okay. And counter ions are here cations potassium. This is the coordinate complex you should assume. Understood? Now between these two you will find the coordinate covalent bond. Between these two you will find the ionic bond. Okay, so there are why this is called as a complex. Okay, complex means where you will find more than one. Okay, suppose shopping complex, that means you will find more than one variety of shops. Okay, then only it is called as a shopping complex. Otherwise it will be a simple shop. Okay, so like that here you will find many type of bonds. First of all, within the metal, metallic bonding. Between the ligand and central metal ion, you will find the coordinate bond. Between the counter ions and this complex ion, you will find the ionic bond. And within the ligand, you will find the covalent bond. Like carbon and nitrogen have the covalent bond. Okay. You will find all four types of bonds in this complex. Okay. What is the first one? Metallic bond. Okay. Metallic bond is found between the iron and iron. Second one will be the coordinate bond. Okay. Coordinate bond is found between the central metal ion and ligand. Okay. And then you will find the ionic bond. Okay. Ionic bond you will find between the coordinate sphere. After this completion, you will find the ionic bond. Within the ligand, you will find the covalent bond. So all four types of bonds you are finding out. That's why this is called as a complex ion. Okay. So now let's see the utilization and rules. Okay. So here ligands are only just they have to donate the lone pair. Understood? So while donating, they may carry negative charge, they may not carry any charge, they may carry positive charge. Okay. They may carry positive charge or they may be neutral organic compounds also. Okay. So negative ligands, for example, NO2 minus, okay, Cl minus, Cn minus, O2 minus, these are all negative ligands. In these ligands, okay, then this type of ligand should either end with IDE, either end should with ITE, either end should with ATE, okay. Then this last AE is replaced by O, okay, chlorido, okay, like suppose Cl minus is there, okay, it is called as a chloride, but in this chapter we are going to speak out and write it as a chlorido, okay, nitrito, oxalato, understood, sulfato, imido, like this, these are the modification in common inorganic naming, and here the difference is that chlorato, bromido, okay. So first negative ligand, what are the suffix you are going to replace? You should change this E in their common naming with O. Okay, IDE. So it will become as a IIDO. Okay, chlorido, nitrito, bromato. Okay, bromato. Like that, E will be replaced by O. Then if it is a neutral ligand, okay, no special ending, and they are used as such. Suppose ammonia is there. Okay, now it is only these are the exceptions. Otherwise, they should be named as it is. Okay, so amine and water it should be called as a aqua. CO it should be called as a carbonyl. CS it should be called as a thiocarbonyl. NO it should be called as a nitrosyl. These are the neutral ligands. Okay. Next, positive ligands. Now positive ligand should end with IUM. Okay. So see hydrazinium, nitrosonium, nitronium. Understood? So these are all these are all table. I will share it on our group. Okay, and that name you can utilize. More and more you practice, the less will be the mistakes and less time you will consume. Okay, so actually there is a saying, practice makes the man perfect. That is absolutely wrong. Practice makes the students perfect, because man is a gender, student is a general name. Understood? So you should practice this more and more questions so that students can succeed. Okay, so organic free radicals are given in their own names like methyl, ethyl, and organic neutral molecule triphenyl phosphine, pyridine. Okay, these are the some. So this will be, you will be more convergent when you go through the table provided by me in the group, and rules and application with some examples I am going to give you. Okay. So I think as of now, if you got any problem, any doubt, you can ask. Okay, in the second slide about the prefixes. As I told you, sequence you will follow first cation. Okay, and in that cation, if it is a complex, then if it is consisting of two kinds of numerical prefixes. Okay, prefixes are generally used when same thing is repeated more than once. Like in organic, we use trimethyl, dimethyl. Okay, dichloro, like that they are called as a prefix. They are numerical, they indicate you about the number of substitutes, okay, available, indicating their number of each type of ligand with the name of coordination entity. Okay, so there are two types of prefixes. How many types? Two types of prefix. Common one everybody know, di, tri, tetra. Okay, suppose ammonia is there, three times, then tri prefix will be used. Okay, so if it is four times, then it is called tetraamine. Okay, so both A and of A, first A and R to be retained. Tetraamine. See, this is very minutely you should observe. Tetra of A of tetra and amine A, both should be written. Okay. A small mistake can give you -1 marks in place of the +4 marks. Okay. So these are all formulated and given to in the slide form because of this purpose only. Okay. I don't want anybody of you should do the silly mistake. The most irritating word coming out from the students after doing the mistake is silly mistake. Okay. So that should be minimized. Now, second type of prefix I told you, it is bis, tris, and tetrakis. Like tetra is now replaced by tetrakis. Tri is replaced by tris. Di is replaced with bis. But where you will use, used with the complex expressions, generally those ligands which you include already numerical prefix in their name. Okay. So whenever required any ambiguity, what is that meaning? Suppose this name is called as a ethylene diamine. Okay. The name of this ligand is what? Ethylene diamine. So its name itself contain di. If it is available three times, then we will write triethylene diamine. So that will create a confusion. That is called as ambiguity. Okay. So to avoid ambiguity of the naming of complexes, okay, so naming of the complexes which already contain di, tri, tetra like this, then they must be written with bis. See here, di is already there. If I write again di, then this will be mistaken. So bis will indicate number of types of ligands it is present. Is it clear to you? So this prefix bis tris tetrakis is to be used only when ligand already contains their numerical prefix in the name itself. Okay. So I think it is understood if it is 2 times bis, if it is 3 times tris, if it is tetrakis 4 times. Okay. So this is about the two types of prefix. I think up to here it is clear to you. Okay. Okay, next to naming of complex ions. So in complex ion, ligands are named first followed by the metal atom. Inside the square bracket, what you should do, you should write the metal atom, then ligands. Okay, ligands must be first, then it should be metal atom. That we will come to know. We are going to do the sufficient practice. Okay, now in the ending of name of the metal depends upon the nature of complex ion. Okay. So if complex ion is cation or it is non-ionic, okay, then the name of central metal atom is written followed by its oxidation state expressed in Roman numerals 2, 3 and 4 in the parenthesis. Parenthesis means in the bracket. And at the end of the name of metal without any space between the two. Okay. 0 is to be used for oxidation state of 0 and negative oxidation state followed by negative sign before Roman numeral. Okay. Now, if complex ion is anion, then name of central metal atom is ATE. Okay. And if anion, then ATE. If non-ionic and cationic, nothing is to be written. Okay. Then while naming the complex acid, transition metal, ICE is used like platinic acid. This is called as a hexaplatinic acid. So these are all you are going to understand better way once I take the examples. Okay. Just I am informing you only rules. Until unless you don't practice, it will not be easy for you. Okay. So after this, we are going to start the examples, and where that time I will quote the rules. That time you will understand the application of rules. Okay. So name of optical isomers, dextro-levorotatory. Optical active compounds are respectively designated either by positive or negative. Either by positive or negative. So RDRL, like this is potassium plus. So plus represent that it is optically dextrorotatory. Okay. Potassium D, dextrorotatory. So it can be written as a plus or D. Okay. Now we are going to start with some examples. Understood? So initially you may not be able to solve. If you are able to solve, then it is well and good. Not able to solve does not mean that you are not knowing. Okay. So with each and every example, I will try to explain the rules. Okay. Now let's start with the rules and the application on the naming. Okay, for example, now you will understand the slowly everything. Okay. So first of all, first rule says that positive ion should be named first. Okay. What is here positive ion? This one. So name will be potassium. Okay. Potassium. First name will be potassium and then coordinate complex. Okay. Then what you should do? Coordinate. Okay, here potassium, why it is written first? Because it is a positive ion. Then our complex is negative. Our complex is negative. In the complex, what you have to do? You have to write the name of ligand first. Okay, this is square bracket wherever it is there. That is a complex ion, and it is in this what you will write first? Ligands first. What are the ligands here? Chlorine. Okay, and how many chlorines are there? Two chlorines are there. So for the chlorines, I should write di or bis. You can understand and you can say I should write as a di or bis. Yes, di, because it does not contain any di-tri word. Therefore, it will be di. Okay, for chlorine name will be chlorido. Okay, chlorido. Okay, dichlorido. Then this total complex is on right hand side. Right hand side means it is a negative complex. So in the negative complex, we should write the Roman name and with ATE. Okay, argentate. Argentate. Okay, in bracket it's oxidation number. Oxidation number is very simple. See, potassium oxidation number is +1, both chlorine oxidation number will be -2. So argentate, silver oxidation number will be 1. Okay, so I think now more of the rules are now understood. Understood. Potassium dichlorido argentate. AT is used because this complex is on the right hand side. These are the examples of anionic complexes. Anionic complexes means on the square bracket you will find the negative charge. Okay. Now you will be somewhat comfortable with the second name. First, what we should write? Second, barium. Okay. What you will write? Barium. Then inside the square bracket, what you should write? About the ligands. And about the ligands also, what you should write? You should write about the number of ligands. Okay. Four are there, therefore you will write tetra. Okay. Then chlorido, tetrachlorido. Okay. Then cuprate. Okay. It will be what? Cuprate. AT I am writing because it is a anionic complex. Then oxidation number. Barium will be +2 and -4. Therefore, oxidation number will be 2. So, cuprate 2. Now, I think all of you are clear. Okay. Cyanide, it will be cyanido. The name of this ligand will be cyanido. I expect all of you to try yourself, pause the video and try yourself, know some name, then I will write the name. Okay. Okay. Now, see, next here, it should be written as next one. I told you this number of times you need not to write. If it is potassium, you should write only potassium. Okay, potassium. Then in the square bracket, ligands first. 6 ligands are there. Okay, hexa. Okay, cyanido. Hexacyanido. Then iron is there. Okay, iron Roman numeral, Roman name, ferrate. Okay, ferrate and oxidation number in Roman numerals. Oxidation number is 3. So this is the name of this compound, potassium hexacyanido ferrate 3. Okay. Now you can try the next question and let me explain the answer. Okay, here let it be number of potassium 4, number of potassium 3 outside the bracket. You need not to write anything. Automatically it will be reflected in the oxidation number. Okay. So here 4 potassium, still I will write potassium. Here 3 potassium, still I will write potassium only. Okay. So potassium, then inside the bracket 6 are there, hexa. Okay, cyanido, cyanido, understood? Then ferrate. Okay, ferrate. Now here you can find oxidation number will be 2. So this need not to write 4 potassium, 3 potassium. Automatically here oxidation number will be changing. Okay. Now here 2 copper are there. Should I write dicopper? No, you need not to write the dicopper. Okay. Automatically it will be reflected here. Okay. So try to write the next complex name. Then I will try to explain if any problem is there. Okay, here next, let it be 4 copper, 1 copper, you write only copper. Then square bracket, in the square bracket, hexacyanido. Actually, this rule is modified afterwards. So earlier it used to be cyano, but nowadays it is cyanido. Okay, hexacyanido, then ferrate oxidation number 2. Okay, now here this ion is there. You have to mention the ion in the last. Okay. Now here it will, there is no metal here, so need not to mention. Then start with the ligands. Okay. So tetracyanido. Okay. Then R8. Okay. R8. AURATE. R8. Oxidation number will be 2. Now this suffix will be ion. Is it clear to write the ions now? Now you can try the next question. Okay. Okay, suppose next one here. So there is no ion outside, therefore you will start with ligand. Now it will be tetra. bromido. Okay. In some books it is bromo. That means it was not changed now. Okay. Bromido. In exam also, if there is no option of bromido and bromo is there, then you can tick that one. Okay. So tetra bromido, cobalt Tate, because it is negative ion. If it is on the right hand side or negative ion, you should write ATE. Okay. Cobaltate, then oxidation number will be 2 and its charge is there, therefore ion. Okay. So now try the next eighth question. Okay. Try it, then you will understand. You will make mistake, you will understand. Okay. Now listen. Tetra, it will be tetra iodido. Okay. Earlier it was iodo, now it will be iodido. Understood? Mercurate. Mercurate, oxidation number 2, then it will be ion. Okay. So same thing, I think you can try the other one. Okay. So try to write this number. Afterwards you can practice this, but try to write this one, 9th, 10th and 11th. Now all of you can try the 11th, then I will write the explanation. 11th and 12th are somewhat difficult. Okay. So let's hope you will do it correctly and shortest span of time. Then I will explain. Check with my explanation. Okay? So now listen carefully. This is the first question, somewhat different. That's why you may feel problem. Okay. So this answer I am writing here. See, there is no cation here. So you should write the complex ion first. Always positive ion first. In the complex ion, you have to write the ligand first. In the ligands, alphabetically first. Okay. So it will be fluoro. C stands for chloro. Okay. C, then ethylene diamine. En means ethylene diamine. Okay. So it will be dichlorido. After this, I will start asking any problem is there. Dichlorido. Then this name contains di. That's why it is bis. Okay. Bis ethylene diamine. Okay. Or ethane 1,2-diamine. You can write it as IUPAC name. En stands for ethane 1,2-diamine. Okay. Bis ethane 1,2-diamine. Ethane 1,2-diamine. Okay. That means now I have written this one also. Then chromium. Here it will not be chromate, it will be chromium. Okay. Chromium oxidation number will be 4. And outside 2 chlorine are there, you need to write only chloride. Outside the bracket, in whatever the number of there, then you need not to mention. See, same chlorine inside the bracket, I have written dichlorido. And this chlorine outside the bracket, only chloride. That is the difference between the chlorine outside and inside. Okay. So once again, check it here clearly. Dichlorido, bis ethane 1,2-diamine, chromium and oxidation number 4, then chloride. Okay. I have read, if anybody having any visual problem, video problem, they can understand now. Okay. Okay, now I am writing the next one. Okay. So here see, for differentiating only I have written both of them together. Understood? And this name I am writing it clearly. Now see here, this square bracket is on right hand side. Right hand side or negative charge, that metal you should write it with ATE. Okay. Here you need not to write ATE chromium. Here you will write it as a ATE because square bracket is on right hand side. Understood? Now potassium 3, potassium is there on left hand side. I should write tri. No, outside the square bracket, let it be 10 or 1. You write only name. Okay. So first it will be potassium. First it will be what? Potassium. Then inside the square bracket, ligand should be there. C2O4 2 negative. From the list you can see oxalato. What it is name? Oxalato. And 3 are there. Therefore, potassium trioxalato. Okay, potassium trioxalato. Okay. Then it will be chromium. Why chromium or chromate? Very good. Chromate. Okay. Then oxidation number. You can find out the oxidation number. You will get 3. Should I write ion? No, because there is no charge. Okay. Potassium trioxalato-chromate and oxidation number 3 in bracket Roman number. There is no charge, therefore there is no ion. Okay. Now if you solve these 12 questions, I think perfection have improved a lot, I hope. Okay. Okay, here this square bracket is on the left hand side. One square bracket is on the left hand side. It is a cationic complex. This name will be cobalt only. Okay, not cobaltate. In this one, you should write the name of this ligand first. Okay, name of this ligand should be first three ammonia are there. So first it will be tri. First letter will be capital. Okay, triamine, A-double-M-I-N-E, triamine. Ligands are mentioned, then cobalt, not cobaltate because square bracket is on the left hand side. Okay, triamine, cobalt, oxidation number 3. Then outside the square bracket, 3 chlorine are there. So simply you will write chloride only, not chlorido, not trichloride. Okay, I think it is clear now. Okay, tetraamine. In the just now I told you special naming for NH3, special naming for water in the rules. Okay. Now let us see the next one. Tetra. Okay. Just now I told you for CO special name is there. What is that? Carbonyl. Carbonyl. Okay, carbonyl. And this is a neutral ligand. In neutral and cationic complexes, ATE is not required. Okay, nickel. And in parenthesis, for zero, there is no Roman numeral. You can write like this nickel. Okay, this is what nickel. Okay, so nickel. Now you can try the next one. Okay, after checking your answer, I could find some misconcepts into your mind. First of all, this is a neutral complex. In neutral and positive complex, iron you will write. If it is on the right hand side or negative ion, negative charge here or right hand side, then you will write ferrate. If it is on left side, you will write iron. Okay, and first you will write penta. For CO, it will be carbonyl. Okay. For penta, carbonyl, iron. Let oxidation number be 0, but still you should write it as 0. Okay. If you miss one word also, then you will not get full marks. For board exams also, I am telling you. Okay. Now you can try this one. It is now left hand side. Some things are both same, like platinum, Greek name also, platinum, normal name also. You can write platinum or platinate. If it is on the right hand side, then it will be platinate. As it is on the left hand side, it will be platinum only. Okay, so first it will be di. Amine spelling A-double-M-I-N-E, amine. Okay. Now it will be platinum, oxidation number 2. Then chloride. If this bracket inside the bracket, chlorido and dichlorido you write. It is outside the bracket, it will be chlorido. Okay. Now you can try this question. I will wait and check your answers. Okay, this is the name here, triamine, trinitro, cobalt 3. Now, some people are still written as a 8. Now, this is neutral. For neutral, metal should not end with ATE. For negative, it should end with ATE. For left side, it should end with cobalt. Okay. Now, let's see the next one. Now, start answering yourself for this one, then cross check with my answer. Okay, now here this is a neutral ligand, so I will write copper, and in this I will write the name of ligand first. Okay, so diglycinate. Okay, diglycinate copper. Okay, oxidation number will be 2. This glycinate charge and structure and denticity all are there in our notes sent by me. Okay, So with that you can understand. For time being, leave that. How you will come to know, you will go through that. Okay, DMG means dimethyl glycinate. Full form is dimethyl glycinate. See here, di is what is there. Therefore, I should use bis. Okay. So here for this bis. Okay. And for this di. Okay. So bis in bracket. Okay. Dimethyl. In bracket, D stands for dimethyl. Okay. Glycinate. Glycinate. Understood? Bis dimethyl glycinate, and it is a simple ligand, therefore simple complex, therefore nickel only, not nickelate. Oxidation number will be 2. Okay. Now here I will explain. See, dichloro. Okay. This is called as a urea. What it is? Urea. Okay. Dichloro bis urea copper. Okay. Here two are there, so therefore it will be bis. Okay. So it will be dichlorido. Dichlorido bis urea. Bracket, in bracket you will write urea, then copper. Okay. Not cuprate. Okay. Copper. Oxidation number will be 2. Now you yourself mark where you felt the wrong and where you done the mistake. That mistakes you should learn. Okay. Here this one again I am telling you, square bracket is on left side or right side, that will affect on the name of the metal, not on the ligand. Okay. This chlorine is inside the square bracket, therefore it is a ligand, therefore it should be chlorido. If this chlorine is outside the square bracket, then chloride. Okay, and that time you should not write number of. Okay, so again I am writing it on the plain board now, then you will understand the differences. Okay, once again, for further proceeding, once again I am explaining, listen carefully. Suppose copper is here. Okay, and here 2 negative. What you will write here? It will write as a cuprate. Okay, again summary where the people are feeling problem, that I am writing here cuprate, because this is negative and in the last you will write as a ion. Okay, now same copper is there here. Okay, some +3 is there, that time what you will write? You will write copper. Okay, and last you will write as a ion. And suppose same copper is there. Okay, some chlorine are there, then for this you will write again copper. Okay, ion will not be there. Now same square bracket, some copper is there, some potassium is there. The square bracket is on right hand side, then you will write as a cuprate. Okay, so all varieties I have told you. Square bracket on right hand side and no charge, then cuprate. Square bracket on left hand side, no charge, copper. Square bracket on center, but without any charge, with positive charge. Okay, all examples I have taken, and one more example also I will take. This one, no charge is there, then also you will write copper. Okay, this is about the metal. Now let us see about the chlorine. Okay, suppose chlorine is there, inside the bracket 2 chlorine are there, then you will write it as a dichlorido. Okay, same chlorine, it is outside the bracket, simple you will write chloride. Okay, now is it understood? So inside the bracket, outside the bracket, the differences, I think it is clear to you now. Okay, take screenshot of this and try to practice them. Understood? These are the combined questions. Somewhere positive, somewhere negative, somewhere neutral, and somewhere two types of ligands. Okay. So write this, and then you will keep your that name. Any book you will find, including NCRT, for OH, what is the charge? What you should write. For ammonia, what is the name? What is the charge? NCRT also, if you keep, don't worry about the notes. The best notes prepared by you is the best notes. Okay. Okay, suppose here one example I will be telling you here, this one. Okay, so this is a positive complex. Therefore, the ligand should be written here. Its name is ethane 1,2 diamine. Di is there, therefore I will write bis. Okay. It will be bis in bracket ethane 1,2 diamine. Okay. Then platinum, not platinate. Okay. Platinum oxidation number 2, as charge is there, I should write as a ion. Therefore, you should write it as a ion. Okay. Note down this. Okay, now this is an example where both positive ion also complex, negative ion also complex. You will have a clarity now. Okay. So this chromium you will write it as a chromium. This you will write it as a cobaltate because it is on the right hand side. Okay. So name I am writing it here. First you should write the positive complex and in that negative ligands first. Okay. It will be hexa. It will be what? Hexaamine. AMMINE. Hexaamine. Okay. Next it will be chromium. Chromium. Oxidation number of chromium is as usual 3. Then here it will be first I have completed this positive ion, then I will switch over to the negative ion. Okay. Now hexacyanido. Now in this one I am writing hexacyanido. Okay, cyanido. Then this will be cobaltate. This will be what? Cobaltate. Okay. Cobaltate and oxidation number will be 3. So after going through this, you can try this one. Definitely you may be not getting, but don't worry. That mistake you will rectify in the next example. After going through this, try yourself, then listen to my explanation. Okay. Okay, here explaining answer. Now listen carefully. So here this total, this is 1, this is 1. That means both oxidation number of the metal must be same. Okay. Suppose if it is written 2 means this is plus 2 here, this is minus 1 here. Okay. Now here first of all I should write this. Okay. So name will be tetraamine. Tetraamine. AMMINE. Tetraamine platinum. Okay. Platinum oxidation number will be 2. Okay. You should know the stable oxidation numbers of metals. And like copper, everybody know it is plus 1 and plus 2. So here it is the even number, therefore it will be plus 2. So here tetrachlorido. Okay. Then cuprate. This will be cuprate because it is on the right hand side and oxidation number 2. Once again, I am reading out tetraamine, platinum 2, tetrachlorido, cuprate. Tetraamine, platinum, tetrachlorido, cuprate. Tetraamine, platinum 2, tetrachlorido, cuprate. Okay. Now you can try the next one. If you are successful in the third one, that means you are perfect in naming. Okay, now I am writing the name of this complex. All of you check with your mistakes. Okay, majority of the mistakes now reduced. Okay, now let us see. It will be hexaamine. AMMINE. Hexaamine. Then left side it is there chromium. Oxidation number of chromium. Everybody knows this. If you don't know, you remember chromium 3. So this completed. Now let us start about this one. 3 is there. So it will be tri. C2O4 name is oxalato. Okay. Oxalato. Then cobaltate. This will be cobaltate because it is on the right hand side. And oxidation number will be 3. There is no charge, so need not to write ion now. Okay. Okay, now these questions you can try on your own. I think I have covered all types of naming. The perfection have gone increased I don't say that now nil mistakes will be there, but the more you practice, that mistakes will be minimized and reduced to zero. Okay, so let's see the. Okay, thank you for watching. I think all of you have done well and you will practice well from your questions, whatever I have given you, and hopefully you will be getting full out of full marks in the IUPAC nomenclature. Okay.